All right, so this video is for group 3. Your learning target is I can determine a function from an equation, a rule, or a description. So the other groups are going to talk about graphs and talk about tables and mappings and lists of points, and then you guys are going to mainly look at equations, all right? You want to take really good notes because you're going to need to teach this to another group in a little bit, all right? So relations and functions are what we're going to start talking about. This is sort of the umbrella here. And these are some of the most important topics in algebra because you are really relating two concepts, so two things that can be modeled after some sort of graph, some sort of equation, and that can help us make predictions later on, okay? So when we talk about these, we're going to talk about them as in terms of ordered pairs, right? Or a point, you may know that as a point. And every ordered pair has an input and an output. So an input is your x, and output is your y, generally. So a relation is the larger set of things. It's any relationship between the inputs and the outputs. So you can see that definition here. The relation shows, oh, I should use the different color, sorry. Relation is the relationship between the inputs and the outputs, or the x's and the y's. So any list of points that you have is going to be considered a relation. A function is more specific than that. So a function is a relation where one output, all right, is you're going to get one output for each input that you have, okay? So for every input, which is usually x, we only get one output, or y, all right? So that's what makes a function more specific, and it's more helpful because we know if we put something in, there's only one possible answer we can get out, whereas when we just have a relation, it's any relationship between the x's and y's. So we might put in an input and get 3 or 4 or 5 different answers out, and that can be pretty confusing, right? So we want to talk about them in terms of an equation, all right? Well, one of the things we know is that equations can look a lot different, right? So we can raise equations to powers, we can have symbols, all kinds of things. But let's start with two examples here, and I'm going to choose an input. So I'm going to let my input be 4, okay? Actually, let's make a, yeah, well, we'll go with it. All right, so my input is 4, or 3. 3 will be easier, sorry. So that's going to be treated like my x, okay? So I want to know what is y when x is 3, all right? And if I only get one output, that's a function. If I get more than one output, it's not a function. So we're going to say y is equal to 5, but instead of x, I'm substituting in 3 plus 2. Well, here y would be equal to 15 plus 2, or y would be equal to 17. Well, how many answers did we get? How many outputs? We only got 1, so that means it is a function, all right? When I put in that one input, oops, I got only one output out, and that's the definition of a function. Let's try that over here with y squared equals x plus 1. So what is y when x equals 3? All right, so my input is 3. So we have y squared equals 3 plus 1. Y squared is equal to 4. Remember, to solve something that's being squared, we can take the square root, and I don't need you to necessarily be able to solve these yet, but I just am showing you for example purposes. So y squared is equal to 4, so y would be equal to 2. The square root of 4 is 2, or negative 2, right? Negative 2 squared gives me 4. and positive 2 squared gives me 4. So there are actually 2 outputs for 1 input. All right? And that's because we had this y squared value, okay? So one of the things that we can sort of summarize here, if y is raised to an odd power, like 1 in this case, or 3, or 5, or 7, it is going to be a function, all right? And you can see that here with our example, but it would also work with a higher power. You're not going to get 2 different numbers. You would get 1 number of the same sign. That answer might occur if it was y cubed. You might get the same answer 3 times, but it's the same answer. It's the same number, so that's okay. So if y is raised to an odd power, it is a function. If y is raised to an even power, like 2, 4, 6, 8, it's not a function, all right? And it only matters what's happening to the y. Y is what determines your outputs, right? The other piece of information is if y is contained within a symbol, like absolute value, like a square root, or this is called a step function or a greatest integer function, it's not a function. It's okay for x to be in those symbols, all right, but it's not okay for y. So that's really important there. And when we talk about, so make sure you have that written down. That's going to be really important and helpful for you. When we talk about function equations, if something is a function, we can then replace y with f of x. So f of x replaces y when an equation is a function. And this piece right here, I just said it, but we read that as f of x. All right, so f of x replaces y when an equation is a function. So if I went back to that first equation that we had, y equals 5x plus 2, well, because that's a function, I could write it as f of x equals 5x plus 2, okay? And this is just a stronger statement. That just tells me, hey, it's a function. We don't have to do any math, any calculation with that. It's just telling me what's happening. So functions are really just rules that are given to us, and they always make sure that every time we put in an input, we get one output out. So you might have heard of the function machine, where we put in the inputs, and we do some rule here, and it spits out an output. Okay. So our rules are really going to be written like equations most of the time. So it's going to be important for you guys to be able to explain or understand what the rules mean. So here's a function, f of x equals 3x squared plus 1. So what I want you to do is describe to me what happens to the input. So when I first input something there, and again, we're reaching for PEMDAS back that we talked about in the beginning of the year. When I input something in for x, right here, what's the first thing that we're going to do to it? So step 1 would be our input is squared, because we always do exponents first, right? Or raised to the second power. After that, the result is going to be multiplied by 3, right? Multiplication comes next. And then lastly, we add 1 to that result. And doing those 3 steps will give us our output, okay? So it's really just taking a math statement and translating it, and following your PEMDAS rules as you go, okay? And then the other thing is maybe taking an equation and writing a function for it. So a painter can paint 300 feet squared, 300 square feet, I don't know why I said that weird, in 1 hour, we want to write the painter's area as a function of time. So this is what's going to be my input after they say function of, and the painter's painting area is the output. All right, so then maybe I want area as a function of time. Instead of writing it as f of x, you can use any two letters, and you want to use letters that make sense for your particular problem. And so time is the input. Time is what we're working with here. So if you can do 300 square feet in 1 hour, oops, then maybe we'd have 300 t, and t is hours, right? And A of t is, that whole thing is the painter's painting area, right? So you can take any sort of situation and you can turn it into a function if, when there's an input, like maybe 2 hours, we have one output. We know in 2 hours this painter could do 600 square feet. In half an hour, 150 square feet. There's only one possible answer we can get, so we can turn it into a function.